So in the previous tutorials, we've learned to use a demux function to take a DVB-T multiplex and output services to multicast addresses, apply out functions to play a TS file in a loop, and a monitoring function to use another stream as a backup as a main one. So in this tutorial, we'll learn how to record it to the hard drive and make extractions out of it. So to do that, we need first a hard drive. So we assume that your system has a hard drive, which is the case here. As you can see, local disk. First, I will click on Erase and Format Disk. That will take a while. So this operation totally erases the hard drive, so you may want to back up anything that you have on it if you used it before, and format it to a Linux format that the OpenHeadend server can use. We usually recommend using an internal hard drive for the recording, but the OpenHeadend solution also allows you to mount network attached storage via protocols like NFS or CIFS. The only problem with that is that if your network falls for one reason or another, you will lose data. So we generally prefer to have the hard drive on the same machine as the function that does the recording itself. So if you also you can make RAID arrays. If you have a hardware RAID, you have to configure it from the BIOS first, and then it will be seen as a single hard drive from Linux. So you would only have to click on Erase and Format once. So now the hard drive has just been erased. I click on the links tab and I can see that there is a new storage link here that is called local. Local means it's a hard drive that is by default disabled, but to mount it I just click on change and enable it. So I talked to you earlier about NFS and CIFS. So in the case of an NFS storage, you have to indicate a server and a path. And basically the same with CIFS. You may also want to have advanced parameters like login, password, and so on. So now that we have a local hard drive, we'll create a node that will be stored on this hard drive. We could create a file node, but a file node would be written indefinitely from the record function, and so at some point we would end up filling up the entire hard drive. So what we actually want is a circular file node. So a circular file node is like a file node, except there is a maximum duration of retention of the data, and after so many days the older files are erased. So let's call it NJ12 record. We bind it to the local storage link, and this menu here proposes you to keep 1 day, 3 days, 7 days, and so on. Let's keep 1 day of NJ12. So as again, we've just configured a node. It currently does nothing. For it to work, we have to bind it to a function. So the kind of function we need is the record function, that we use the NJ12 monitored multicast address as an input. It's more interesting to use the monitored node instead of the raw DTT one, because the raw DTT one will be empty if the DTT fails for one reason or another, and so you will end up with an empty file when you do extractions. So that can be a bit disturbing. Whereas if you use the monitored net node, you will be able to see, well, the panel or the animation that you've put instead, indicating that something went wrong. So it's more user-friendly. We need to configure an output node, so that would be our circular file, and then I just click apply. If I have a look at the workflow, it's been extended with these two items here that says we're writing the NJ12 stream to the hard drive. So there are several uses of this circular file. The first one is it allows you to do time shifting with a plot function, just like this one. So let's create this. So I will need the plot function, but also need a multicast address. So let's say integer 12 time shifted. That we will output to Ethernet on the production network, like this one. And so we'll bind that to a plot function, like before, that uses the node we've just created, and a circular file plot. So circular file plot is a bit more complex. This is an input, so that's the circular file we're just creating, and a delay. So here we have 1 day. Of course, we don't have 1 day of record on the hard drive. We barely have a minute, so we'll configure it for a minute. If you select it as 1 day or multiple of 1 day, it may be interesting to set a time zone, because if you do set a time zone, it will handle the daylight saving times appropriately. So the plot function is now working. As you can see, after our record function, we have a circular file, and the circular file is used as an input to the plot functions to the time shift stream. Now let's have a look at the time shift stream. So this is energy 12 from 1 minute ago. Another use of the circular file is the ability to do program extraction using the manage content again button. So the idea of the program extraction in the manual way is that you can set an offset, a start offset, an end offset, and preview what was airing at that time. But since we don't have that many recording time so far, we'll just see what happened in the last minute. For instance, at that time, click play. So this is a preview of what was airing at that time. I can go forward in time or backward in time from this point in time. So here you have the time that is currently playing down there. If I'm satisfied and I say that this is the start of my program, of what I want to extract, I click set. Then I can move again forward, for instance by 1 minute, and I can say that this is the end of my program, so I just click set again, and I'm happy. I have the start and end offsets of my program. So now I just need to set a name for a file. If I click on download to file, it will be downloaded to the local browser here, so on my PC. I can also use the copy to node function and select a directory node that can, for instance, be on a NAS, and click on copy, and in that case the file will be copied directly to the NAS. So that can be used to then automate transcoding, for instance. The OpenHeadend server also provides the EPG data as a helper. Of course, EPG is not that precise, so you probably have to tune it using play and set. If you have more precise data, like for instance something coming from an ASRun log, you can import an XML file and you will have a list of presets here. From which you can create also batch extractions from all presets, or just use one preset at a time and refine it with the play and set button and click copy. So that's basically the idea on how you extract programs from the OpenHeadend server. So that is manual or semi-manual using presets. There is also a fully automatic way that is possible. You would do that by creating extraction jobs in the schedule 1. So I talked earlier about schedules. Schedules allow you to start jobs at given time. There is also one special schedule that is the first one, that is for temporary jobs. So with this schedule, jobs that are in this queue are automatically run when when it's possible to run them. And so an extract job, you generally don't need to do what I'm about to show you, because a script will be able to do it. But the script just has to select an input node, so that's our circular file, a time offset, a duration, and an output. So a directory to which you want to copy it, a file name if it's needed, and then you click on and then you click on apply in that case, but the script would do it for you, and it will create an extraction job that will run whenever it's possible to run it. So that was the recording function with time shifting and also program extraction. Thank you for following this tutorial, and I hope I'll be able to talk to you a bit more later on new functions of the OpenHeadend server. Goodbye.